Well, good evening, grade 11s. A couple of people have been asking me how to answer these questions on the second worksheet, so I'm going to post. I'm just going to give you a hand. Okay. So yeah, don't forget we have a quiz on Friday morning at 10 o'clock. So that's exciting, and it'll be like the practice quiz that I posted here. So I'm going to post answers to this a little bit later, but just to show you how you do questions like this. Okay, these are energy problems, so let's just get right to it. Okay, so look. Okay, question number 1, it says a bird is flying with a speed of 18 meters per second over the water when it drops a 2-kilogram fish. If the altitude of the bird is 5.4 meters and friction is disregarded, what is the speed of the fish when it hits the water? All right, so question like that. What you want to do is think of it like this. Here's your little, okay, I'm not good at drawing, but here's a little bird, okay? And there's his little face. Here. There's his little face. There's his little smile, whatever, okay?
Like a plane.
And then he's got his, here's his little feet. And he's got his fish here. There's his fish. Okay, and then what he's going to do is he's going to drop it into the water. Now you don't need to draw a diagram to do it, okay? But I just want to show you how you do a question like this. So he's going to drop it. It's like a projectile. You can even do it with the projectile motion equations, but we're not going to do it that way. We're going to do it the energy way. Okay, so here's the deal. I'm going to break this into 2 parts for you, the top and the bottom. Okay, and that's what you need. That's how you need to think of these mechanical energy systems. Like there's 2 spots here at the top. Oh, let's see. Hang on, he's not quite at the bottom, is he? Oh, yeah, it is at the bottom. It hits the water. All right, that's fine. So here we know this height is 5.4 meters. Okay, that is the height. Okay. All right, so I'm going to make a little thing here. At the top, what kind of energy is in the system? Now for you, there's only 2 kinds of energy to consider, gravitational and kinetic, okay? So we know that the bird at first is moving at speed is 18 meters per second, that's the fish too. So at the top, what kind of energy do you have? And the answer is, you have both of these, okay? Why do you have EG? Well, because you have height. And why do you have EK? Well, because you have speed. So at the top here, at the top, the fish is moving and it has height. So it has both gravitational potential and kinetic energy. Okay. Now at the bottom, down here at the bottom, once the fish falls into the water here, when it reaches the bottom, okay, I'm going to list the 2 kinds of energy down here as well, EG and EK. Well, here the height is 0. Okay, we're not going to really worry about it going any lower. So that means it doesn't have any more gravitational potential that we have to worry about. But it's got speed, and what they're asking us for is the speed, right? So it definitely still is moving and therefore has kinetic energy. Okay? Now, the way you break these questions down is like this. The total mechanical energy has to stay the same. So in other words, the energy at the top, okay, the total has to equal the total energy at the bottom. Okay? So at the top, you're going to go mgh is your gravity. Here, actually, let me write it out in a separate step. Eg plus ek at the top equals ek at the bottom, right? So mgh plus 1/2 mv1 squared will have to equal 1/2 mv2 squared. Now, if you look at this equation, the mass cancels because it's in every single term, so you can cancel it. So we don't, even if it gives you the mass, we don't need it. Okay, we know what V1 is. V1 is your speed initially. That's right there. So your V1 is 18 meters per second. Okay, we know H is 5.4 meters, so we know everything on this side of the equation. The only thing we don't know is V2. So we're going to solve this for V2. So you're going to go therefore 9.8 times 5.4 is h plus 1/2 times 18 squared equals 1/2 times v2 squared. Just solve it for v2. And you're done. Isn't that easy? Okay, no problem. So anyway, this method, this is what we call the energy conservation method. Okay. Okay, so that is the energy conservation method. The total energy stays the same. Okay. All right. So now that you've got some idea on what to do, let's try the second one. Okay. So in the second question, it says a diver drops from a board that is 10 meters above the water surface. Now this word drops implies that V1 equals 0. Okay, so just so you can parse the information. Okay, this is your initial height, call it H1. And this is H2, your final height. It's not really final, but anyways, part way down. Okay. They're asking you again to find V2. Okay, and that's it. So here's the deal. You don't need to draw a picture, but I'm going to draw the picture for you because it probably helps to visualize these things. So here's your platform, here's your water. The guy starts up here. Okay, V1 is 0. Now, this is 10 meters high, but then later he's down here, okay, whatever, and he has dropped 5 meters above the water line, so he is now 5 meters above the water line here, and they're asking you for V2. Okay, like that. Now you could use motion equations to do this if you wanted, but we'll use the energy method because that's what this is all about. All right, so again, at the top, what kind of energy do you have? You have Eg, okay, because you've got height, but you don't have Ek because V1 is 0. Okay. At the not at the bottom, but at the 5 meter mark, you still have Eg. So here at this mark, so you're going to have both of these, okay, at the bottom. So what you do is the energy at the top equals the energy at 5 meters. So therefore, okay, mg H1 equals mgh2 plus 1/2 mv2 squared. Again, the masses will cancel. Don't need those. And they give you them that you can figure out as mass. They give you as weight, so you can figure out as mass, but we don't need it, honestly. So the mass often cancels in these problems. And again, we're going to solve for V2. We know H1 is 10. We know H2 is 5. Okay? So now all you have to do is solve for V2. And that's it. Okay? All right, so now, look at the next question. So what if V1 was equal to 2 meters per second? What if you ran off the board or jumped off with a certain amount of speed? Well, if V1 is not 0, then you're going to have mgh1 plus 1/2 mv1 squared equals mgh2 plus 1/2 mv2 squared. This is really the general equation that you can use every time. This time though, H2 is 0 because they hit the water. They strike the water. Okay, so this time, this one is 0. And V1 is not 0 this time. V1 is 2 meters per second. So you just got to solve that equation. Basically, guys, you're solving this equation here. I'm going to circle with a nice, pretty rainbow. That's the equation you're solving every time. Okay, it's basically an energy conservation equation in a mechanical energy system like this. Okay. All right. So in this question here, you're looking for you take your initial height as 0. Okay, so I'm just going to give you some hints here. H1 is 0 in this question. You're looking for H2. Okay. Here, V1 is equal to 2.2 meters per second. And V2 equals 0 at the top of the jump, approximately 0. Okay. And so what you're doing is just solving that same equation with those variables. The mass will count. They don't give you the mass this time. Don't need it. Okay. Number five, the pendulum question. Like again, it's released implies that V1. I'm sorry, let me zoom in so I can write it a little better. This implies that V1 is 0. Okay. You're looking for H1. What's the initial height? So that the speed of the bottom implies that H2 is 0, right? Okay. Of the swing is 1.9 meters per second, so that is V2, 1.9 meters per second. Okay, and then what they're asking you for is what is H1, what is the initial height, okay? So that's it. So just go ahead, plug the numbers into, again, to the rainbow equation there. That's it. That rainbow equation says it all, okay? You do that every time. All right, I hope you enjoyed that, and have a good night, guys.